So hi, everyone, and thank you for joining me here today. Hopefully, we will be able to see each other face-to-face next year when things go back to normal. But for the time, I'm just welcoming you from the sunny Barcelona. My talk, as you can see, it's called the Art of Front-End Architecture, and I want to talk about front-end and front-end architecture because I feel that over the years, we as an industry, as a front-end industry, we've asked for responsibilities, mostly because our platforms allowed us to do so, our tools evolved, our ecosystem evolved, and they become powerful enough to do more stuff and to become more responsible and less depending on other technologies and other platforms. So nowadays, I think it's kind of an art to find the right balance between handling all this complexity and also applying the, good battle-tested practices to develop software that allow us to provide value to our users, which is why we are here. I'm Adria Fontcuberta. I'm a senior, whatever that means, software engineer at Holaluz, an energy company based in Barcelona, where we try to connect people to green energy, and we're doing so for our more than 300,000 customers. I'm also a member of the official Vue.js utils library, the official testing suite for the Vue ecosystem. And I'm also a member of the testing library family, right? I maintain the Vue testing library. So if you're into Vue and testing, I got you covered. Shoot me a tweet. That is my Twitter handle. And also my website where I share random thoughts when it comes to software development and so on. So let's get to it. I wanted to start with an brand advisory due to explicit content, because I'm going to show you what legacy code looks like, right? We've all been there, and even if we've been there, it is the starting point of our quest here at Holaluz to write maintainable front-end applications, right? We don't start from scratch. We start from legacy projects, and we need to evolve how to do things to make sure that we can support the business growth that it's expected from us. So this is what legacy code looks, right? As you can see here, I won't go into details, no need for that, but this is a JavaScript code. There's some highlight here. For instance, this is a PHP file written in JavaScript, because why not? Notice the indentation of the file. Nothing good can come from it. We also have the usual suspect. We have jQuery here. We have also Bootstrap. So yeah, the arrow here. And finally, notice the scroll bar, right? So this is not looking good. And we could mock this for a long time. This is production code, so it is code that is making us money. So let's not forget that. But let's try to see it as a learning opportunity, right? So what can we learn from this code? What can we do differently to avoid ending up in the same state in several months in the future? We kind of we made this exercise and we discussed with the team, and the first thing that we noticed is that actually all this code, you could split code into chunks, into groups, right? Depending on its purpose, right? So for instance, we noticed that there was some parts of the code that are related to the business, let's say, right? If you see the image here, we talk about powers, about consumptions, about tariff, everything electric, energy related. And other lines are just about displaying things on a screen. So some parts of the code are related to the business itself, it's the core of the application. And other parts are just there to make sure that this business rules, this business code is delivered to the user. And we could map changes of code to either one or the other purpose. So we thought, what if instead of just merging it as it's shown here, what if we just split the whole thing into two groups, create a crystal clear separation between the business stuff and the delivery stuff, right? creating a clear separation of concerns, which is a well-known software practice. And we try to make sure that changing delivery code, right, delivery stuff, does not have consequences on our business stuff. And this is something that we should aim for, that we are willing to aim for. And let me show you an example of why this is important. Let's say that instead of being in an energy company or electric company, let's say that we're just building something simpler. Let's say we're building a tic-tac-toe game. Hope everybody knows what tic-tac-toe game is. But it's based on 2 players. You have this board with 3 rows, 3 columns. You need to make a straight line to win, and we all know the rules, right? So all these rules, all these mechanisms, all the logic that creates a game is what we would call the business stuff, right? And this doesn't change depending on the way that we play the game. So for instance, we could be playing tic-tac-toe game using a web application made in your favorite front-end framework. But we could also be playing on a native mobile app, right? From your iPhone, your Android, whatever. But you could even play tic-tac-toe using a paper and a pencil. So we could have several delivery mechanisms for the same business rules or the business stuff, right? So this is something that we want to make sure that our code is able to do. We have the defined business stuff, and we have it isolated from the delivery stuff. Moreover, what we discovered is that this business stuff, it's kind of big, right? There's a lot of things going on in there. But we noticed that we usually have this group of objects, of elements or concepts. For instance, we have in a tic-tac-toe game, we could have a game, we could have a board, we could have users, so we could have, I don't know, a scoreboard, whatever. And then we have a list of interactions, of ways these these objects can interact with each other. So when we talk about business stuff, we usually say that a piece of code is something, right? Like when I say this piece of code is the user, this is the game. But then I also say things such as, then the user does something, right? The user starts the game or the game finishes. So we noticed that making this distinction clear between what software is and what software does was kind of useful. So we did so, and we used well-known terms to make this distinction, and we named them domain and use cases, right? So domain is the group of code that defines what software is. You can say a software is a tic-tac-toe game because it has the game, the board, the users, and so on. But then you have the use cases, which is like, let's say it's like a shopping list of what software is capable of doing, right? It's a list of the ways domain stuff can interact with each other. So we have these 3 groups of code, these 3 layers, and we could just draw them as if domain was the core of the whole application. This is where the universe of the application is defined, right? Where concepts exist. This universe is wrapped in a layer of use cases in a way that make this domain objects interact. And then there's the truck, right? Then there's the delivery layer that makes this whole use cases execute or whatever, or just they make it available to our users. So let's talk about the delivery, right? The delivery layer. Delivery layer, it mostly, it gets data and displays data also from different sources. And it mostly does so from 2 different streams of data. It does it from, external APIs, for instance, when you request something to your backend application, from local storage, from cookies, whatever. But it also gets data from user, right? So for instance, when a user clicks on a button, when it fills a form, this is also data that fits our use cases. So having this distinction of these two streams of data is kind of useful as well. So since we have 3 layers already, we just created a 4th one. This is called the infrastructure layer. This is where we get and persist data. And then we have the UI or input data. Right? As I mentioned, the infrastructure layer is just about API repositories, external ones, cookies, a web storage, so local storage, JSON storage, and whatnot. And the UI layer is just the UI. And here, after we created our 4th layer, we just sit back and discuss for a bit. What are layers? Layers of software, after all. They do not exist in software, right? They are just, I don't know, they're just a convention. They are just a way to group parts of our application and that allow us to reason about them. But they also allow us to define some rules on how these layers can interact with each other. And that's one of the most powerful traits of layers, that we can create rules on them. And one of the most important rules, and one of the foundational rules for this whole thing to work, is what is called the dependency rule, which states that dependencies only point inwards. And when I say dependency, if we're talking JavaScript or TypeScript or whatever, it's literally when we use an import statement, right? When you import a file into another one, you are creating a dependency between those files. So what we're saying here is that the order of layers matter and that dependencies can only point inwards, which is the same as saying that an inner layer should never rely on anything from an outer one. So straight to the point. Let me just share a couple of quick examples to make sure that we're on the same page here. Let's say that our application, our tic-tac-toe game, has these features, this use case where you can get user information. Let's say that you can have your profile name, your avatar, your whatever. And this use case depends on the user, right? It kind of makes sense. So we know that the use case is from the use case layer, and user is something stored in our domain layer. So this is following our rule, right? The use case depends on the domain object. That's cool. On the other hand, let's say that we have the same use case, the same get user information use case, that kind of depends on a framework feature. Let's say that it forces an update on Vue, React, or Angular, or whatever, or depends on a specific feature of a framework. What we would have here is a use case depending on an external layer, and this is what we don't want to see in our code. Notice that this has several reasons, and maybe one of the most important ones is that if we wanted to test this use case, this get user information test, we would need to instantiate the whole framework. The setup would be much more complex, and changing the framework would make the use case change, and this is something undesirable. Okay, so that was a lot. And some of you might be thinking, okay, Adri, that sounds reasonable, but why are we complicating this? Wasn't the web supposed to be much simpler? I mean, why all the hassle? Well, my answer is that this is important because given this pattern, given this structure, the web is just a delivery mechanism, right? The web lives in this. It's the track, right? It's the delivery part of our application. So here, what we're saying is that the web is not the center. The web is external. It's not the main goal of our application. So we're changing the mindset here. We are not developing let's say, a Vue application to play tic-tac-toe. We are either making a tic-tac-toe application, which is made in Vue, right? So other matters. However, the web, I grant you that the web is really hard. It's hard to get it right. The web is really complex. there's a lot of process, a lot of specs, a lot of tools, I mean, it's really complicated. So we don't want to, let's say, pollute our present, our use cases, our domain with all this complication. We need to adapt its content. We need to adapt the content of the web to make it manageable for our inner layers. So we literally need something that translates all this complexity into something that we can reason about. So we literally need, yet another layer. That's the last one, I swear, to adapt that UI. So in the end, we have these 5 layers, which we can group easily. We have the domain, the use cases, infrastructure, so the layer that gets the pulled data from outside sources and sends it back, that are independent from the framework. They have nothing to do with any modern framework. They are completely independent. And then we have the UI layer and its adapter, which are the framework itself. So here you could just be able, in an ideal world, you should be able to maintain the same domain, same use cases, the same infrastructure, and then change your UI framework and use whatever you want to use. So this onion graph is kind of useful, but to see the explicit relationships between layers, let me just spread them over and create and show that the dependencies between these layers. Notice that here, if we just divide the screen, on the left side is our track, right? We have all the tools that get us data or sends data back. And the right side of this diagram is our gift. It's the app itself. And obviously, the user interacts with the UI. So the UI is just a tool, a really complex one, but just a tool that allows the user to execute, to start a use case that makes the domain objects to interact. And you might be thinking at some point, okay, but how does this fit our current patterns, right? How this whole structure, this whole idea fits something such as Redux or Vuex or state machines or whatever, right? Those are cool tools, right? We don't want to lose them. We've already learned them, and then the whole reactivity thing is one of the reasons that that promote the usage of modern front-end frameworks. Right? How can do I need to forget all of this? What we discovered trying to apply this pattern is that when we have this structure, the key part here is that this adapter, the layer that helps us translate all the complexity from the UI into our use cases, is a perfect match for our state management libraries, such as Vuex or Redux or whatever. And this is our current approach. This is what we've been trying to apply for the last several months. And now, enough talk, show me the code, right? So now I'm going to share you some possible implementations of this just to make sure that we're on the same page. But first, a disclaimer, this is not the right way. Now you're going to see some TypeScript. You can see TypeScript on the back. You can see some classes. I have some model slides with JavaScript and no classes. So this is not about programming paradigms here. I'm just trying to show how this can be implemented, not the actual implementation. So try to bear with me. So let's say that, okay, this is we're still making a tic-tac-toe game, right? So this is what the domain layer could look like, right? So notice how here we define several concepts of our universe. We have coordinate, signs, board, cell, applier, right? So we have several of these items that exist no matter the application, no matter if we're playing on a web application or using a pen or a pencil. We could also have a game, right? We're still in the domain layer. And notice how here we can, again, know how to make a move, right? This make move function, these are the business rules to being able to make a move on a tic-tac-toe game, right? The game should not be ended. You should have not played last, and the position should be empty. If that's the case, then you can place. Notice how testing this is so easy. I mean, there's no framework involved. You just need to pass a different combination of layers and cells and the states and just make sure that the appropriate exception has been thrown or so on. Notice that this is, as I mentioned before, this is focused on, this is a object-oriented example, but functional programming would also work, obviously, and that's beyond the point, let's say. And notice how this game just can make a move given a player on a cell, but we need to make them interact with each other, right? And this is where use cases enter set the stage, right? Notice how here, okay, now we dropped TypeScript, so everyone is happy. Now we are using functions, no classes, so yeah. Notice how this use case is kind of interesting because first it gets some values, right? So it gets a game, a player, and a cell, and then it makes them interact with each other. Notice how we call our game.makeMove, and we pass down the parameters. But also, notice the important part, how here we implemented a couple of callbacks that get called either, I mean, if the use cases, the movement is successful, then we call unsuccessful, otherwise we call on error. Notice how we are performing some inversion of control here. So the implementer of this use case, the responsible, the piece of code that's invoking this use case is going to decide what happens or what to do depending on the result of the use case. Now, this example is really simple, so bear with me. Imagine a more complex use case that involves some sort of more complex interactions or some sort of notifications or logging or something. This example is really simple, but notice how it is also easily tested, right? You just need to provide some game, player, and cell, and given the combination, just assert that the right callback has been called. No framework yet. So we have our domain, we have our use cases, and now let's make it execute. So here we're on a tic-tac-toe application made in Vue. So this is Vuex. And notice how on the first line, we are importing our use case from application. This is our adapter layer. Notice the relationship here, right? We're importing the use case. So this is following our rule. Notice how we have this make move action, which triggers the use case. Let's assume that it gets the player from state, game from state as well, and then we get the right cell from as a parameter, whatever. This is just, I just made this up. And on success and on error, I just do whatever I need to do, which is totally coupled to the framework in this case, right? We're committing this action. So this is 100% coupled to Vuex and Vue. Notice that this layer, the important thing here to note is that it doesn't think, right? This layer just translates. It calls the use case, it knows what parameters the use case is expecting, and just provides its values. It can be tested as well, but however, bugs here are really easy to spot. If you're using TypeScript or linters or whatever, as long as you provide the right parameters, it's really hard to get it wrong. And since it's just a wiring between the UI and our use case, any bug is easily spotted. And while this might seem trivial, notice how we could replace Vue and Vuex here and still do the same thing. Let's say that instead of having this cool modern framework, let's say we're stuck with jQuery. This is what the same use case looks like when invoked from jQuery. Notice how we're still getting player, game, and cell from random places. We're using the amazing jQuery API on success. For instance, we're using the fading method, which is amazing, right? And on error, we're just displaying a window alert. Notice how the layer is still dumb, right? It doesn't know how to make a move on tic-tac-toe, right? It just provides the right parameters and provides the callbacks implementation. So it doesn't matter what framework implements the use case. This use case is still using, it's written somewhere else, tested, and so on. So this looks like a joke, obviously, but it's kind of, I hope that you see the power on this. I was about to finish, but I wanted to share some disclaimers here. For instance, you might not need any of these. Notice that this has some benefit, but it also comes with a cost, right? That's more in direction, which means more lines of code, more concepts, more learning. So this, I guess what I'm trying to say is that it doesn't come for free. It has some benefits, but you need to pay for them. However, you might want some parts of it. You might, we've been adopting these ideas as we go. We haven't performed a big bang change, a big bang release. We're just trying to test some of these ideas, change its value, and adapt the result. For instance, isolating the framework is something that could make sense. You might not need to split domain and use cases just yet, but you might be just doing it for without knowing. For instance, it's quite a common practice to extract the API calls from components or from the implementation themselves. You have all these API calls in a separate file. That's the idea, right? So just try to reason about it and see if you are already applying some of these ideas. And the second disclaimer is that nothing here, nothing that I explained here today is new. This is based on clean architecture, domain-driven design, internal architecture. It was already invented. And actually, there was this tweet from a year ago, right before this little pandemic started. But this tweet from my developer said that, "Hi, I'm a JavaScript developer. I like to take software design patterns from the 70s and present them as new ideas to my front-end developers." And well, right in the fields, because that was just my talk. I was just trying to share with you some ideas that are way older than me and that they just work. So wrapping it up, this is what I wanted to share with you today. I wanted to share the idea of organizing code around business rules, not the frameworks. Framework should be treated as an implementation detail. This is not to downplay frameworks. They are awesome. They provide a lot of tools and power to users, and they enable to create amazing experiences. But still, the business rules should live outside of them, as my point of view. To do so, the dependency rule is one of the most important ideas to follow, which is basically keeping details away from the core, right? So the core does not need to know anything about who is delivering it to our users. And since we are trying to build maintainable software that can keep on providing value to our users for months and years, we need to make everything easy to test, right? You cannot have maintainable code if that code isn't testable and tested. So creating all these layers help us test the important parts and make sure that we are testing the right thing. And finally, notice how we've been talking about software development practices, software design principles, even if we are talking about front-end, right? And this is because front-end development is also software development. So everything that we've been learning the last decades when it comes to good software development, sensible software development, it also applies to front-end. We're just another side of the same coin. And this is all I wanted to talk to you about today. You can find me on Twitter, on my website, on Notice. You have available the slides and the talk if you need to check them out. I hope you find it entertaining and enlightening. and stay safe.